Hello and welcome. My name is Ankur Shah, and I'm a research associate working on Earth Science Data Management as a member of NASA's Impact Team. The Impact Team is a group that works to maximize the scientific return of NASA's missions and experiments by improving the use of and access to Earth science data. We also explore advanced concepts such as machine learning to enhance our understanding of our beautiful planet. As a team, we created this challenge to solve the problem of phenomena detection on satellite imagery. This is an important task for many reasons. Natural phenomena can have major impacts on our ecosystems, economies, and safety. And satellite data is a powerful asset that is used by researchers across the globe to understand and mitigate the effects of these phenomena. Now, obtaining the data in general is not a problem. NASA produces massive volumes of satellite remote sensing data. However, none of that data comes pre-labeled to show where the interesting phenomena are located. So imagine you had 50 years of satellite data from all over the world, and you wanted to study the effect of dust storms on crop yields. How would you even determine where or when the dust storms occurred? Well, one solution would be to carefully look at every single piece of data and label all the occurrences of dust storms by hand. But of course, this can take months or even years of work. However, with today's technology, we can instead develop machine learning models to automatically detect phenomena and then output those results to the researcher. This is where you come in as the challenge participant. To meet this challenge, you will create a machine learning model to detect a specific phenomenon. Then you will build an interface that not only displays the detected phenomena, but also layers it alongside ancillary data to give researchers and decision makers additional insights. And finally, if your team has the capacity or the time, we have outlined a bonus task. We will explain each challenge step in more detail as we move along. The first thing your team will need to do is choose one phenomenon to detect. This choice of phenomena is important. Ask yourself if the phenomenon impacts our society, if it is scientifically interesting, and most importantly, whether satellite data is available for your machine learning model. When searching for satellite data, there are two major categories to consider: labeled and unlabeled. So by using labeled data, you can immediately start training a machine learning model. However, because only a small number of phenomena have been labeled, your choices will be limited. So we've provided labeled data on a Google Drive, which you can access along with other resources in our GitHub repository. Alternately, you can use unlabeled data taken directly from satellite imagery. By doing so, you will have a much larger selection of phenomena to choose from. However, if you go this route, you will need to find and label your own data and possibly pre-process it as well. And this could take a lot of time. So to make this task easier, we have provided some resources. So first, you will need to download satellite imagery. There are several resources listed in the GitHub repository, but here's one example: NASA Worldview, a tool that allows you to interactively browse over 900 global full-resolution satellite imagery layers, and then download that underlying data. After downloading the data, it will then need to be labeled for machine learning. So here on the Impact Team, we have created a tool called the Image Labeler to facilitate this task. Image Labeler is a tool that allows you to either take satellite imagery from NASA's MODIS instrument or to add your own custom imagery. Then you can create labeled data by simply drawing spatial bounding boxes around the phenomena. Image Labeler is a convenient all-in-one system for creating training datasets. And if you choose to go this route, it will serve a greater purpose beyond the hackathon, as any labeled phenomena datasets will be valuable to researchers. Now let's talk about the machine learning model. Your model should take in satellite imagery as an input and then automatically detect the chosen phenomenon. It is not as useful to simply tag an image as containing a phenomenon. So if possible, the algorithm should generate a bounding box around it or output specific coordinates. We've provided resources on how to create a machine learning model on our GitHub repository. The example Jupyter Notebook shown here is a model using neural networks for dust detection. This script trains a model on high-latitude dust or HLD images and performs new detections. We use the MODIS RGB satellite product as the input. which is labeled for dust events using Image Labeler. We use a special type of convolutional neural network model called UNet. This model assigns a class label to each pixel of the input and gives an output with the same size. The resulting output, once trained with high latitude dust or HLD masks, will segment any given image to HLD and non-HLD pixels. To validate the model performance along with metrics such as accuracy, visualizing the outputs is crucial. Here in this example, we use the matplotlib library for visualization. We create a plot with three subplots. The first one has the input image. The second subplot overlays the manually assigned labels over the input image. And finally, the third subplot shows the model predictions on the input image. You can use this example template to help create your own phenomena detection model and be as creative as possible in the visualization of the detections. For visualizing your model outputs, add data alongside the detections to show the societal impact of your chosen phenomena. For instance, you can visualize smoke detections alongside population data, or layer flood detections alongside socioeconomically vulnerable populations. For the bonus task, explore ways to augment the data before training. So this would mean removing unwanted features like clouds from satellite imagery, or using style transfer for incorporating data from multiple sources in the same model. The main focus of the challenge is phenomena detection and visualization, so you should only do a bonus task if you have the capacity or if it contributes to the main tasks. If you have multiple people on your team, this challenge presents opportunities to work in parallel. So once you've chosen a phenomenon, the first step we recommend is to brainstorm the outputs of the detection model. So ask yourself, what will the phenomena detections look like? How will you display them on a map interface? Then think about the types of ancillary data that you might want to display alongside the detections to enhance your model output for your final product. Remember that visualization is the key to showcasing the societal impacts of your phenomenon. So once you have a good idea of your final product, we recommend dividing the team tasks into visualization, machine learning, and data labeling if needed. Consider splitting the tasks based on the interests and expertise of your team members. And remember to work on the challenge steps in parallel. You've heard multiple mentions of the GitHub repository, so here it is. Our repository contains all of the mentioned resources and more for identifying and extracting data for specific phenomena. This repository is divided into labeled data, raw data, examples, and resources. Each section has readmes which contain links to publicly available satellite datasets. And example scripts which allow you to download and label phenomena data along with the machine learning pipeline have also been provided. Please visit this GitHub page as it will minimize the time you spend on finding the right resources and help your project succeed. The link to the repository is in the video description below, so please check it out. We have provided our contact information in the resources section of our GitHub page, and we're here to support you in our Space Apps Challenge. We hope you learn a lot during this challenge, but most importantly, have fun. So thank you so much for watching, and on the behalf of Impact, we wish you the best of luck. Thank you.